welcome back. Now in this video we are going to solve one simple problem which is based on the merging of two sorted arrays. Okay, so this problem is very important and also this is the prerequisite for the merge sort algorithm. Okay, so if you are going to learn the merge sort algorithm, then in that case at some point of time there you will be using this concept that we are going to learn in this video. Okay, and in the next video we will see that what the merge sort algorithm actually is. Okay, so let's start with this video. Okay, so in this video you can see that here is the problem statement saying that write the program to merge the two given sorted arrays into the single array such that the resulting array also becomes sorted. So what does it say is that you have two arrays which are already sorted in ascending order. Okay, so for example, let's say that you have sorted array in ascending order as 2 4 6 8, and another next array is like 1 3 5 and 7, right? So these two arrays which are already in sorted, okay, these two arrays you have. Now your task is that you should be able to merge this such that the whatever array you get after the merging, that array should be also in sorted in ascending order. That means for this scenario the correct answer will be what? Yes, so 1 2 3 4 5 6 and 7, right? So this should be your answer for this question. So we are going to see that how to merge this. Okay, so before that let's understand the concept. Okay, so if you see it properly, what is happening here? So see the first element of that of the both arrays, right? So take two variables I and j. I will be pointing to the first variable of the array of the left array. Say the first array is left array, right? And the j will be pointing to the first element of the second array. Okay, now what you need to do is that compare the elements at the position I and at the position j. In this condition, at this stage, the I and j are at the starting of the arrays. Okay, so we are going to compare the 2 and 1. If whatever value is smaller, I am going to put it here. Okay, and I am going to increment the value of j by 1. That means if you say of I is greater than this array of j, right? That means we need to put this one into this array at the first position, and after that we will be decrement this j value from 1 to 3. Okay, now the j is pointing to 3 and the I is still pointing to 2, right? Again we will compare same, that which one is the smallest among these two. So in this case 2 is the smallest, that means 2 will be printed here, right? And the I will be incremented such that it points to the 4, right? Now again you do the same stuff by comparing the 4 here and 3 here, right? So which one is the smallest? 3, of course, right? So you are going to again put that 3 into the third position and increment the j from pointing from 3 to 5. Now you compare 5 and 4, right? Which one is smallest? 4. Again you put 4 here, okay, and increment the I such that the I now point to value 6. Okay, so keep on doing this, you will get this final array, right? Now if we are going to code this example, so let's write the simple C program to solve this problem. Okay, so what I have done till now is that I have two variables n1 and n2, which are the size of the two arrays. So the first sorted array is LRR, which is representing the left array or the first array, and the second one is RRR, which is representing the right array or the second array. Okay, so remember that both these arrays should be sorted. That's why and then we are scanning the values of the both arrays. Okay, now let's write the function to solve this problem. Okay, so I'm going to write the function merge here. Okay, and inside the merge what I'm going to pass is something like the left array, the right array, the size of the left array, and the size of the right array. Okay, now we are going to pass this into the merge function. Now we'll be declaring the merge function here. Okay, so the return type of the merge function will be of course void, because whatever changes you will make, okay, you are going to make inside there only. Okay, see, so this is going to the merge here, and as I have taken the LR first array as this and the next array as this, and the size of the first array is n1 and the size of the second array is nothing but it's n2, right? Okay, so after that I am going to define Okay, so after that I am going to define another variable n, which is the actual size of the array after merging. Okay, so n will be n1 plus n2, right? So say you have the n1 as 4 and n2 as 5, then if you merge these both two arrays, then you will get an array of size 9, right? So that will be of course n1 plus n2. Okay, it's easy, right? Now I'm going to declare the actual array which we'll get after merging these two arrays. Okay, fine. Now, so as we have seen that we need to compare the we need to declare two pointers, say int I equals to 0 and int j is also equals to 0. So at this point they both are pointing to the first element of the both the arrays. Okay, now I will be using the condition while I is less than n1. Remember that we are considering here zero based indexing, right? Okay, and j is less than n2. Okay, so we'll come on to this condition later, that how why this should be the condition here. Okay, we'll come here, okay, at the later stages of this video. First let's see that how to do the comparison part. Okay, now I will be using the if else statement. So I will write if LRR of I, because I is pointer for the left array, right, and j is the pointer for the right array. Okay, yeah, fine. So if you find LRR of I is equals to RRR of j, then in that case what you need to do, you need to put ARR of k is equals to LRR of I, and you just increment the I and increment the k value also. So till now I have not defined k. Okay, so k is here now, k is pointing to 0 again. This k is pointer for this array. Okay, so that we can store the value after comparison. Okay, fine. Or else if this is not the condition, then what should we do? It's quite simple, right? We should do array of k as RR of j, and here I will find j plus plus and we'll do k plus plus. Okay, so you have completed this part. Okay, that means half part of this program is done. Okay, now let's see that why is this condition is here. Okay, why this condition is correct here. So let's take the same example here, right? So let's say the I was initially 0, okay, and j was initially 0. Okay, so you compare both, you find that one is smaller, you put here. Now now j is pointing to 3 and I is pointing to 2. Again you compare, you got 2 here. Okay, similarly you got 3 here. Okay, 3 here. Similarly you got 4 here. Again you got 5 here. Again you got 6 here, right? Again you got 7 here, right? Now at this point, if you see, when we got 7, right, so the value of j will be how much? If we consider the zero based indexing, then the value of j will become how much? It should be 0 1 2 3 4, because 7 has come here. That means it will not be pointing to 7, but somewhere after 7. That means at that position the value of j will be greater than the or equal to this size of the array. Okay, so in this case the value of j will become 4. That means at that time when the value of j has become equal to n2, then we just need to exit the while loop, and whatever the remaining elements are there, either it is in say in the first array or in the second array, we just need to put here. Okay, so once you completed the 7th part, then in that scenario the j will be pointing to 4, somewhere 4, which is irrelevant in this case, and I will be pointing to 8. Okay, since j is pointing to the irrelevant value, or it is equal to the size of the array, hence whatever the elements which are remaining in this left array, in this case it is 8 only. Okay, if we are going to put here, so in this case 8 is the only remaining element there. Okay, fine, is it okay, right? Let's take another example. Say one array is of size 2 and the another array is of size 4, right? So I will be pointing to 2 initially and j will be pointing to 1 initially. Okay, so you compare both this, you get 1 here. Again, the I will be pointing to 2 itself, j will be pointing to 3 itself. Okay, now again you compare, you got 2 here. Now I will be pointing to 4 and j will be pointing to 3 itself. Again you compare, you get 3 here. Now the I value, if you see, is still pointing to the 4 and j value is pointing to the 5. So you compare both, you got 4. Now once you got 4, the I value has become 3, sorry 2, right? If you consider the zero based indexing, that means the I has become equal to the size of the array. So our algorithm says if you find that any of the pointers, either a or j, becomes equal to the size of the array, then in that case whatever the remaining elements are there, you just need to put that into the ARR or the actual array, right? What I'm saying here is that if you say after printing 4, the j value has become equal, the I value has become equal to the size of the array, which is 2. Okay, so once it becomes, so hence what are the remaining elements still to be compared are 5 and 7. Okay, so you just need to assign or put it the 5 7 as it is into the actual array after the merging. Okay, so this is the basic algorithm. Okay, so this is why we have taken the condition that whether until you need to run the while loop until the value of I is less than n1 and value of j is less than n2. Okay, it cannot be equal to n1 or greater than n1. Okay, and whatever the value it is remaining, either it may be the case that say the array with pointer I has been exhausted, that then in that condition you need to put the elements of the second array into the array. Okay, so for that what are you going to do is that I will still say the same condition that, oh look, it should be while loop here. Okay, yeah, fine. So oh look, if j is less than n2, then you do the same stuff that we were doing earlier. Okay, you just assign this. Okay, and you just do j plus plus and here k plus plus. Okay, will be applied for what? For the opposite condition. That means if the j value has become equal to the size of the array, then you just need to assign all the values that are there. Okay, so yeah, fine. Okay, that are there. Okay, so I will do here only. Okay, so ARR of k is equals to LRR of I. Okay, and I plus plus and k plus plus. Okay, now you just print the array. Okay, so we'll just print that array. You just print this array and you just return from here, right? Okay, so you also need to get a return from here, return 0, and now compile this as 2t.c. you can see it has compiled successfully. You just do t2.exe. okay, and just say the first array I'm going to choose, the size of the first array is 4 and the second array also 4. Now I will input the first array. Let's say I input it as 2, 4, 6 and 8, and next array is 1, 3, 4, 5 and 7. You can see the sorted array has come here, which is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is the basic funda behind this problem. So if you have not understood it, I know that it's quite difficult to understand at the first instant only. Okay, so please see this code. Okay, and try to trace this code using this example, using any example in your mind. Okay, so try to trace this code. You will get to know that why I have chosen the conditions in the while loop as such like this. Okay, I have tried my best to explain you, but you should also try your best to understand yourself, to make you understand yourself, and that can be done by only by tracing the code or self-studying or coding by your own, right? So that's it for this video, and I think that we are now well prepared to go and learn the merge sort algorithm. So see you in the next video. So thank you and Jai Hind.